Before understanding orthogonality in group theory, first let's understand what orthogonality and vector space are. A vector space is a collection of objects that can be combined linearly, like vectors. For example, spatial vectors x, y, and z, wave functions psi1 and psi2, and these are a few examples of vector space. Now, coming to the orthogonal vectors. Two vectors are said to be orthogonal if their dot product is 0. Suppose we have two vectors A and B. If they are perpendicular to each other, then their dot product will be A dot B cos 90, which will be equal to 0. When two vectors are orthogonal, they are said to be independent of each other. But not all independent vectors are orthogonal. Here, the independence means one vector contains some information that cannot be generated from the other. One vector cannot be expressed just by scaling the other. Like A cannot be expressed as a scalar multiplication of B. Suppose I have two vectors such as 1, 2 and 2, 4. These two vectors are not independent vectors because the second vector is a result of scalar multiplication of the first vector. So, both vectors point in exactly the same direction. But if we have 0, 1 and 1, 0, then they are independent vectors. Because they point in a different direction and they cannot be expressed in terms of each other. But are 1, 0 and 1, 1 independent. Here 1, 0 cannot be mapped into 1, 1 by scalar multiplication. So, yes, they are called independent vectors. But they are not orthogonal vectors. As stated earlier, not all independent vectors are orthogonal. If you take the dot product of these two vectors, then it will not be 0. So, orthogonal vectors are a special kind of independent vector with 0 overlap. That naturally raises the question: why introduce a special term, orthogonal, if independence already exists? Because orthogonality gives something much stronger and mathematically cleaner. For example, the vectors 1, 0 and 1, 1 are independent as neither vector is a scalar multiple of the other. However, they are not orthogonal because the second vector has a component along the direction of the first vector. Orthogonality means completely separated. Examples 0, 1 and 1, 0. Here, we can say one vector is purely x and another is purely y. They do not overlap at all. Orthogonal vectors make mathematics incredibly simple. They do not interfere with each other. Orthogonality is the backbone of irreducible representations. In the next video, we will see the importance of orthogonality in designing the character table.